Well, let's now look at using Cramer's rule to solve a system of three equations, three variables, three equations. And it's very similar to what we saw with the system of two equations. You do have to be careful how you set things up. And so down here we have the three equations, three variables. And up here at the top, we have kind of what our rule is. And let's just kind of go over that just a little bit. If you notice in this first column for the x, what we have is the values of the constants. And then we come back in with the y coefficients and the z coefficients. All right. So in other words, what got replaced with the x values in the matrix of the denominator? We moved the constants over there. Now, we're trying to find the y value in this middle section. Look, that's the x coefficient. Now we got the constants, and then we've got the z coefficients. And so again, in place of the y coefficients, we put the constants, in this case m, n, and p, what everything is equal to. This would be like -7, -19, -15. And then when we do the z, look, we got the x coefficients, we got the y coefficients, and then we got the constants. And then, of course, in our c, that's just simply the coefficients of the x, y, and z variables in each of those rows. As long as the determinant of the c. And so then we find the determinant of all these and divide the determinant of the x, let's call it, over c, y over c, z over c, the determinants of each of those to find our ordered triple. So let's go here then to the next slide. And like I did before, I want to go through all the time of entering the matrices, each matrix individually. But here you can see that we've got to find the x, we take the constants, the y values, and the z values. Those are what I build into each column. Find the determinant of that. In this case, it's -345. For the y, it's the x, it's the constants, what I call the constants, followed by the z coefficients, and the determinant of that's 855. For the z variable, it is the x coefficients, the y coefficients, and then the constants, and that determinant was -465. And then finally, for just the coefficient matrix, it's the x, y, and z coefficients in all of the three equations, and that equals -30. So when we take the determinant of x over the determinant of c, we get -345 over 330, and that equals 23 over 22. When we do the y, we got 855 over -330, and that equals, if we reduce that down, that reduces to -57 over 22. And then for our z variable, we take the -465 divided by the 330, and that reduces to 31 over 22. And so our ordered triple is 23 over 22, -57 over 22, and 31 over 22. So let's quickly look at one more. So here we've got a system of equations, three variables, and then once again, if I'm building my matrices, for the x variable, it's the constant over the y coefficients, z coefficients. To get the y, it's the x coefficients, the constants, and then the z coefficients. And then for the z coefficients, it is the x and the y and the constants in each equation. And that's all divided by the coefficient matrix of the x, y, and z variables. And I went ahead and just entered the matrix. You can see, go back, look at those equations, rewind it a little bit, see how I put in those numbers. But for x, the determinant is -1537. For the y, it's 1920. For the z, it's -384. And for the C matrix, it is or actually D matrix, but when I actually put them in the calculator, it's 384. So in order to find the x, y, and z value, I take the determinant of the x matrix, negative 1536, divide it by 384, and we get negative 4. I take for the y variable, I take the determinant of the matrix that I set up for the y value, 1920 divided by 384, which equals 5. And then for the z variable, I take the determinant that we set up for the z's, negative 384, over the c determinant of the c matrix, 384, which is negative 1, and therefore my order triple is negative 4, negative 5, negative 1. And I think you'll probably agree there. Once you get through the setup and making sure that you're setting up each matrix properly to solve for a system of equations, 3 variables, 3 equations, it's probably much quicker and much easier than solving it using substitution and elimination. Now, there's actually other ways that we can do it with matrices. There's the Gauss elimination, Gauss-Jordan elimination, and I don't know if we get to it in this Algebra 2 course. We definitely do in the pre-calculus course, some different ways of using matrices. But matrices are our friends, and that's because our calculators are our friends. Have fun.